Dear students, how are you? Hopefully you all are doing well. This is Amit Saha, lecturer, Department of Mathematics, Milestone College. Today we are going to discuss about chapter 5, that is your permutation and combination part. Dear students, this is the only chapter where we can get huge marks by writing very small part, but you must have to make your concept clear when you are trying to solve all the maths from this chapter. Today I have discussed a math where there will be rules will be followed. Hopefully if you can observe this math very clearly, it will be very benefited for your upcoming exam, not only exam but also for your admission too. Okay, let's have a look our today's class. So dear students, today our discussion topic is permutation and combination, and here in this chapter we are trying to focus on one math, and this math will be represents all types of methods. Okay, our first math is from example 2 in your chapter 5, that is permutation and combination, and the question is find the number of ways in such could the word equation, so from this word, be arranged under the following condition. So there is some condition, we have to find some solution from that condition, but here is given a word that is equation. Since the word is given, we have to arrange the word, that means we have to go for the permutation part. So here what we have to do, first of all, taking all letters at a time, that means if we take all letters from the equation, then what will be the arrangement of it? So the word equation consists of 8 letters. 1 2 3 4 5 6 7 8, and all are different. It's a very important thing. 8 letters and all are different. Since the word equation has 8 letters and all are different, then if we take all letters at a time, so the word equation from here actually, so the word equation can be arranged by taking all the letters at a time is 8p8, because there is 8 options and we have to take all the letters, that means we have to take all letters, because we have a formula, that is if we have taken n numbers, from the n numbers and the arrangement will be npn, that is n factorial. So it can be also say that it is 8 factorial. So what we have to write, we have to write from this given part, that is the word equation can be arranged taking all letters, by taking all letters at a time, is equals to 8p8 or 8 factorial. So if we use calculator, then we'll get a value, and that value will be approximately 40320. So this is how we can solve these types of math. So what actually happened here? Here is given a stream, and this is the question number 1. there is a lot of questions from there. So our question number 1 says there is given a word and you have to rearrange or arrange that word by taking all the letters at a time, and that problem can be solved by this way, that is the word equation can be arranged by taking all the letters at a time. That is we have 8 options and we have to take all 8, that is 8p 8. So our answer is this is the answer of first question. Okay, let's move on to question number 2. So here our second question is with this stream, taking any 4 letters at a time. In the previous math we have 8 options and we had to take all 8 numbers or all 8 letters, but here we have to take 4 letters from that 8 letter. So what we have to write? We can write like this in the word equation. The word equation consists of 8 letters and all are different. So this is the line what we have to write for every time, and all are different. Okay, the word equation consists of 8 letters and all are different. So what we have to do? We have to take only 4 letters. So what we have to write? The word equation be arranged by taking any 4 letters at a time will be what? We have how many options? Exactly, we have 8 options and we have to go for only 4 options. So from 8 options we have to arrange only 4 letters, so 8p 4, and if we calculate this then it will be very much approximately 1680, and that's the answer. So this is how we can solve these types of math. My dear students, this actually line or these types of words we have been found from this team. No need to memorize this, we just have to understand this part. That's why at the very first time when the video was started, I was talking about this is the chapter where we can get more numbers from a very small math. So if we can understand only this part from the total circumstances, then we can say only for this you will get 2 or 4 marks very easily. So the concept must be clear for this chapter actually. Okay, what about our next math? So our here this question says that taking 4 letters at a time so that Q being at the start. So this is a solution procedure and this line must have to be written at the very first line, that is the word equation consists of 8 letters while all are the different. So first of all, how many options we have? We have 8 options, that's the very first thing. And second thing is we are going to talk about only 4 letters, taking 4 letters. So we have 4 empty places. Okay, and in these 4 empty places there is, according to our question, Q being at the start, that means Q will be staying at the very first position. So if Q staying at the very first position, then how many options or how many work we have to do? Actually we have to work for these 3 places. And how many options we have? we had 3 options, but now 1 options have been removed. So now we have 8 minus 1, that is 7 options, and from that 7 options we have to use only 3. So we need 4 minus 1, that is 3 options. So here is 3 places and there is all 7 words. How? Very clearly we have been seen EQUATI when, where this Q option has been rejected, because this Q option has been rejected. Why? Because this Q have, or this Q come in the first position. So the rest 7 letters, or among that rest 7 letters, 3 letters will become these places. So how we can go for that? So the word equation be arranged taking 4 letters at a time, so that Q being at the start is 7C3. That means our answer will be 7C3 if we 7P3, and it gives answer that should be 210. That's the answer. Why we are going for P or C? I was talking about very first time that here is the arrangement or arranged, so we are going for the permutation, that's why we have to use P. So it will be 7P3, and that is 210. And you know that the combination and permutation we are very discussed about our first lectures, where we are going for some basics of those. However, so that will be our answer of question number 3. And our question number 4, there is some difference in it, and that very small difference is question number 4 says Q being at the start, okay, but N being at the end point. What does it means actually? It means that at the very first position Q will become, and at the last position N will come. So in which or for which places, or for how many places we have to work for? We have to work only for 2 places. And how many options we have? We have already reduced 2 options, because Q is come first and N has come at last. So we have actually 1 2 3 4 5 6. We have 6 options. So from these 6 options we have to choose 2. So the answer should be 6P2. You may also write like this way, that since Q and N has already selected, so we have actually 8 minus 2, that is 6 options we have, and we have to work for 2 places, because there is 4 places and 2 places have already booked, so there is only 2 places. So the answer should be 6P2, and the answer of it, if we use the calculator, then we'll get 6P2 will be 30. Okay, so this is how we can solve up to question number 4. Here our question number 5 says taking 4 letters at a time, so that, very important thing, Q will occurred, but N never occurred. So there will be no N on that 4 letters, but Q occurred. That means Q can take any places of that 4 place. Since you have only take 4 letters, that means we have 4 places. So 1 2 3 4. In these 4 places Q can take any place. Q may stay in here, or here, or here, or here. So for Q there will be 4 options for Q. Then how we can write it? We can write it like this way. So any place out of 4 places can taken by Q, by which way there was 4 place and Q will take only 1. So here say our 4 place was that, and say for example Q was staying at this place, though it has all 4 options, but we can think that okay, Q will stay at here. So our rest 3 places was available, and in these 3 places how many options we have. Here q is already coming here, but n cannot be occurred, so n has the option which I have to remove first. So how many options we have? We have 1 2 3 4 5 6, so we have 6 options, and we have to take 1 2 3 letters. So the word equation be arranged taking 4 letters at a time so that q will occur but n never occurred is equal to this 4p1 is multiplying with 6p3, and it can be written much more clearly like this way. So the answer should be 4p1 into our, we have actually 6 options and there was 3 empty places. I think we all have remembered this. Here was, say for example, q, so all 3 empty spaces here, and there was 6 options. So if we multiplying these two, then it will be 4 into 6p3. 6p3 is very much equals to 120, and 120 into 8 is nothing but a very easiest answer. It should be 480, and that's the required answer. So dear students, what we have been done in here, I am trying to make you more clear at these types of concepts. If your concept is clear at the case of this math, you can do any types of math in your regular time. Okay, so first of all, here I was talking about 4 letters at a time so that q is occurred, n is never occurred. So q is occurred, then q will occurred in where, or q will placed at which place, or how many options for q. For q there was 4 options, that's why 4p1, that is 4. But at the case of second thing, that is q will occur but n will never occur, that means how many options we have available? We have 3 empty spaces and we have 6 options was available since n is not acceptable. That's why we have 6 options and we had to go for 3. So 4p1 into 6p3, and that is our final answer. So this is how we can solve our question number 5. So our question number 6 says that taking 4 letters at a time involving repetition. Involving repetition, if this word comes, then you can think that this is a gift for you. And for these types of problem, we have a very useful formula, that is fixed divided by fixed to the power not fixed. Fixed to the power not fixed. That means here what actually talking about? Here I was talking about taking 4 letters at a time. So we can take any of the 4 letters. Do you think that 4 letters is fixed? No way. Why? Any of you can tell me that EQUA, we are trying to take these 4 letters, but if anyone trying to take that 4 letters, or QAIN, so this is not fixed. So these 4 letters is not fixed, but here all the numbers, or all 8 numbers are fixed. Since all 8 numbers are fixed, so according to this formula, our this math solution should be 8 to the power 4. 8 to the power 4 should be our answer, and then the answer would be 8 to the power 4. Okay, and another question I wanted to talking about, then how many ways we can wire, or I can wire 2 rings in my 5 fingers. What I was talking about, how many ways we can wire 2 rings in my 5 fingers. Here our 5 fingers is fixed, but 2 rings are not fixed, or wiring 2 rings in a finger is not fixed. That's why on that time our answer should be 5 to the power 2. Okay, so involving repetitions, if we have, then we can go for this formula, that is fixed to the power not fixed. Okay, so let's move on to question number 7. So our question number 7 says taking 4 letters at a time, which 2 or more letter could be same. Dear students, here all are the different letters. Since here all are the different letters, then we can't say that 2 or more could be same. Then how we can go for that? Then we have to go for first that how many ways it will become, that is involving repetition. When I was talking about, that was 8 to the power 4, and we have also found that here is total 8 numbers, and from 8 if we take 4, then it will be 8p4, and if we subtract both of that, then we'll get our answer. So what does it means actually? This represents that involving repetition. I mean, how there will be so much repetition in here, repetition, and here there was 8 letters and 4 had been taken, and we can already understand that there is no repetition, so it should be no repetition. So if we just going for that way, that total minus no repetition, then we will get 2 or more could be the same. So we are going for this answer little bit tricky, that is repetition minus no repetition, then we will get our original and final answer. Okay, now let's move on to question number 8. So here that is talking about taking one vowel and 2 consonant, so that the vowel in the middle. So how many options we have to choose from the 8? We have to choose only 3 options, that is 1 vowel and 2 consonant. But one thing was also given here, that is vowel in the middle. So that means this is the place where we have to take a vowel, and these 2 are the place where we will go for the consonant. So we can take vowel from how many vowel from here? In this equation all of the different, that's true, and here we also observe that there is 5 vowel in here. There is 5 vowel, 5 vowels, and that is E, U, A, I, O. So these 5 vowels are here. So from this 5 we have to take only 1, and Q, T, N, 3 consonant. Q, T, N. Okay, so from 5 vowel we can take 1 by 5p one way, and from 3 consonant we can take 2 by 3p 2 ways. So this is the way we can go for the answer. So our answer is this. So how we have been how we can write this? We can write that the word equation be arranged taking 1 vowel and consonants, so that the vowel is in middle, is equal to 5p1 into 3p2. Or we can write it like this way, that 1 vowel can be found by 5p1 ways, and 2 consonant can be found from the 3 options is 3p2 ways. And finally we have been write those words, and if we multiply that 2, then we will get our final answer. Clear? Okay, now our next math. So here question number 9 says taking all letters at a time, so that constant may occupy the even place. Okay, so here the very important and interesting thing, that is the place, even place. How we can go for the even place, or how can find from the even place? Here is how many places is there in equation. In equation there is actually 8 places, 8 places, 1 2 3 4 5 6 7 8, and in these 8 places this is the second place, this is the 4th, 6th and 8th. So there is 1, 2, 3, 4. There is the 4 even places, and in these 4 even places we can put these 3 consonant. By which way or by how many ways? That is 4 is the total places, and where we'll put 3 consonants. So in these even places, or in 4 even places, we can place 3 consonant by 4p 3 ways is multiplying with. So if we select this place, and this place, then the other 5 places will be staying at the 5 vowel by 5p 5 ways. So that's the answer. How we can go for this? First of all, our even places we have been found, that is 4 even places, and in these 4 even places 3 consonant has been placed. So if, say for example, these 3 places has been selected for the consonant, so how many places is empty? 1, 2, 3, 4, 5. So in these 5 places our 5 vowel will be occupied, okay, or placed. Then we'll get our answer. Okay, that is how we can solve question number 9. So in question number 10, taking all letters at a time so that vowel is occurred at the start. What does it means? So this is the starting point, and in this starting point 1 vowel will be come. But how many vowel is there? There is 5 vowel. From 5, 1 vowel will be coming in here by 5p 1 ways, and after that the rest 7 places will be placed for the rest 7. So that will be 7p 7. That's the answer. So how we can go for that? Our first place was placed or by replaced by the vowel by, there was 5 vowels, so from 5 1 will be coming here, and the rest 7. Say for example we are selecting O. So how many are option available? 1, 2, 3, 4, 5, 6, 7. So these 7 will be placed in 7 places. So that's the answer of class number 10. Question number 11 says, taking all the letters at a time so that all vowels will remain together. So all vowel will remain together. That means that all vowel will be counting as number 1 number. So this is 1 and there is 3 consonant. So how many numbers are there? Exactly, there is 4 numbers. So 4 numbers is there. So this can be arranged by 4p4 or 4 factorial ways. Clear? How I have been written here. Taking all letters at a time so that all vowels will remain together. That means all vowel will be remain together. That means vowel will be conjugate by each other. That means it will be counting by 1. This is 1 and there is 3. So how many places or how many total numbers? 4. So it should be 4 factorial. But in this 5 vowel can be remain there's in every ways, or it can be arranged by among its own. That means so here these 5 vowels can be rearranged by themselves by 5p 5 ways, 5p 5 ways or 5 factorial ways. So the answer should be 4 factorial into 5 factorial. A 4 factorial has come from how? These 3 consonant and 1 because of togetherness. This 4 factorial, but this vowel can be rearranged by themselves by 5 factorial ways. So this is the answer of class of number 11. So here if the question is like this, like question 12, taking all the letters at a time so that all vowels will not remain together, then how we can go for that? We know remain together, the answer of remain together was 4 factorial into 5 factorial, and now since it is not, that means if we subtract from the total, there was total was 8. So from 8 factorial, if we subtract this, then we get our answer. Okay, why it is 8 factorial? Because it is 8p8. It is 8p8. These are total minus what? Remain together. Remain together is what? 4p4 into 5p5. Clear? And we have already known that for 8p8 is 8 factorial, 4p4 is 4 factorial, 5p5 is 5 factorial. So this is the answer, and if you write like this way, then it will be also answer. Okay. Here number 13 says that taking all the letters at a time without changing the position of the vowel. So without changing the position of the vowel, that means what actually? EQUATION. This is the equation. So here actually the position of EUATO, these position are fixed. We can't what? Placed or displaced them. So what we can do? We can only change this position. And how many position is there? There is 3 position. And how many options we have? We have 3 options. So our answer should be 3p3, that is 3 factorial. That is our answer. So what we have been done? Changing without changing the position of vowel. That means vowel will be straight, but the position of the consonant can be changed. By which way? Here is 3 places and there is 3 numbers. So 3p3 is the answer. So it is 3 factorial. Similarly, the question, if it is said that without changing the consonant, then what will be happen? So taking all the letters at a time without changing the position of consonant, then actually QTN, that was the straight part, but this vowel can be changing. By which way? 5 factorial. On that time our answer was exactly 5 factorial. So I think you can understand the math number 13. So question number 14 says that taking all the letters at a time without changing the relative position of vowel and consonant. It's a very interesting thing. Relative position of vowel and consonant, that means the position of vowel can be changed only the position of the vowel. So the position, say for example E, U, A, I, O, these are the position can be changed by this. E can be go there or there or there or there. Similarly, all 4 can be come in these positions. Relative position, that means it can be changed by these only 4 options. So it has also the 4 options. That means this 5 position can be changed by 5 ways. Similarly, this is for the vowel. Similarly, this same work will be also applicable for the consonant. So consonant has 3 options. So it is 3p3. That's the answer. So changing without changing the relative position of vowel and consonant. So without changing the relative position, that means they will be just replaced by themselves. So 5p5 into 3p3 will be the answer. So here there is given that all the letters at a time without changing the very important word order of a vowel. Order of vowel without changing. So vowel order cannot be changed. So here how many vowel is there? There is 5 vowels. 5 vowels. So since there is talking about order, that means total divided by vowel. So the answer should be 8 factorial by 5 factorial. That's the answer. But if the question was like this, that taking all the letters at a time without changing the order of consonant, then the answer should be 8 factorial by 3 factorial. This is how we can solve these types of maths. So dear students, it was a very big lectures, but I am trying to touch all the type of these chapters. Hopefully this lecture will be very benefited for you. Thank you.